Okay, so let's talk about this second concept question. Let's just sort of talk through what's happening here and how you should think about working the answer. So we have two bullets of equal mass. We're shooting them at equal speeds at equal blocks of wood on a smooth ice rink. So there's no friction. The first bullet, which is made out of rubber, bounces off the wood. The other bullet, made of aluminum, burrows into the wood. In which case does the block of wood move faster? So if we can think about what's happening, think about it in terms of momentum conservation, right? So these two bullets are going at the same speed. They are hitting two equal blocks of wood. And this means that this guy's momentum is the same as this guy's momentum. They have identical momentum, which means that the total of the system before, in this case, is going to be the same as after momentum, and also in this case. These two situations will have identical momentum after the collision. So the momentum after should be in that same direction. This value and that value are equal. Now, in one situation, I think it's the first one, the bullet hits it and then bounces back. In the second situation, the bullet hits it and basically kind of lodges in there. And then it's going to go off at a particular velocity, and this is going to go off at a particular velocity. And we're trying to figure out which one's going to move faster, this one or this one. So in this case, let's look at this case for a second. In this particular case, the momentum of the bullet and the wood will be the same because it's an inelastic collision and they're going to travel off at the same velocity together. Now, bullets are very small, so it's not going to impact the total mass to where it's hugely significant. But the key thing here is that the direction of the motion is the same as it was before. Okay, so let's just say that this momentum is 5. Let's just make up some numbers to play around with it, just in case you're struggling here. Let's say that the initial momentum is 5, because they both have the same mass, both have the same velocity, and let's just say it's 5. This is not a real value. Bullets are like 300 meters per second, and we can do the math and all that, but let's just play around with simple numbers. In this case, our after momentum is still going to be 5, and this is still going to be 5. But look, this direction, okay, for here, this momentum is going to be 5 because there is no change in direction. They go off together in this direction, so the momentum of this one thing has to be 5 because there's nothing to add to it. It's got to equal what it was before. The before momentum is 5. The after momentum is 5. They collide inelastically. The bullet sticks into the wood, and they go off together. But look at this first situation. This bullet bounces back, which means its momentum is opposite the original total momentum's vector. So let's make up a number here. Let's say that this momentum is 25, going this direction. In order to equal 5, what does this vector now have to be? This vector now has to be 30. That's a pretty big difference between 5, right? If this vector is 5. So because it's got a greater momentum, it still has the same mass, basically. I mean, this has a bullet now lodged in it. But so even with that, it's got less mass than this one. It's got a greater momentum than this one. So it should have a greater velocity. Since V equals P over M, 30 divided by some number is going to be higher than 5 divided by some number. So this scenario right here, the first one, will actually give you a much higher motion or velocity of the block of wood than if the bullet were to stick in the block of wood.